All right, so now we're moving on to the next section, D, theoretical probability, and we're still in chapter 14. After this, we have one or maybe 1.5 more sections to cover, and then we'll be done for this chapter. So we definitely should have enough time to finish this before we leave for winter break. And remember, that's what we want. If we can finish this before we leave for winter break, then you don't have any homework over winter break. Otherwise, you'll have to study. All right, so our objectives for this lesson is to understand what an event is. We've already talked about this in the last video a little bit, but just to understand it a little bit more. And then we're going to find the probability of a given event happening. Find the probability of a given event occurring. Let me add that to it. All right, so now what we mean by this is if I say, what are the odds? This would be an easy one. What are the odds or find the probability of flipping a coin and it landing on heads? It's nice and easy, all right? But you should be able to say, well, you have a 50-50 chance of that happening. So finding the probability tells us the likelihood of the event occurring. All right, so let's go ahead and we're going to talk about this a little bit more and then go through an example, then that's it for this video. All right, so here's this little example that I thought would be good. So it says, when rolling a dice, a single die, our sample space is 1, 2, 3, 4, 5, 6. Because when we roll a die, we have 6 different sides that it can land on. So those are our sample space. Remember, the sample space is anything that can happen. Since the die is cube and therefore symmetrical, we expect that each of the 6 outcomes will be equally likely to occur. That is the key thing. When we're talking about this probability, we need to make sure that all of the events taking place are equally likely. When I talked about flipping that coin before, we need to make sure that it is a fair coin or that the dice are fair, meaning that the odds of you rolling a 1 is the same as you rolling a 6. They're not weighted in any way. The coin isn't changed or altered in any way to make a heads or a tails land more often. So we say that they are equally likely, and that's what needs to happen for us to be able to talk about this probability, at least that we're learning right now. And we say that the theoretical probability of any given outcome occurring for this die is 1 out of 6 because the odds of us rolling a 2, as they're saying here, we have 1 2 that we can roll out of 6 different sample spaces that can happen. So it's 1 out of 6. All right, so we're going to go over just real quick a formula of how we can do this. But the way that you're going to remember this, it's the event that we want to take place. So the event that we want to take place. Meaning in this case, we are looking specifically for rolling a 2. So we were only looking for the 2 over the total sample space. Whoops, that's really, really sloppy. Sorry. All right, so in this case, we had 6 different outcomes that we could have. So that's why it turned to 1 over 6. So these are the questions that you're always going to be asking yourself. All right, so now let's just talk about real quick the formula that we have for this. Sorry, I just wanted to add this definition with it as well. And then we're going to talk about a little bit more that little fraction that we wrote up. So remember, an event occurs when we obtain an outcome with a particular property or feature. So in the time before, we were rolling a 2. So the event that we were looking for was rolling a 2. All right, but the event can be one thing like rolling a 2, or the event can be something like rolling an even number. All right, each of these are events that are taking place. The difference is when we are just saying a 2, we have one possible outcome that can happen with the 2, and one thing that we have to take into account. When we're rolling an even number, we need to think about, well, on a die, we have 6 different numbers. We have 1, 2, 3, 4, 5, 6. So on a die, if we're talking about an even number, we actually have 3 different things that can happen that are still an even number. All right, so now, what I talked about before, if a sample space has n number of outcomes which are equally likely, right? Equally likely, that's the key thing, to occur when an experiment is performed once, then the outcome has a probability of 1 over n occurring. Or the way I want you to remember this, the probability is the number or the event that you want to take place. That goes in your numerator. And just like I just talked about here, that can be one number, rolling a 2, or it could be multiple numbers. In this case, we would have 3 different events that can occur that give us an even number. So sometimes it's just going to be a single number Sometimes there'll be multiple events that can also satisfy our constraint. So whatever event we want to take place, rolling a 2, rolling an even number, that goes in our numerator. And then the total outcomes or sample space will go in our denominator. And we're looking at the number, total number, let me add this. This is our total number of outcomes or the total number of sample space. Right? And that's the way that you figure out your probability, because what it's saying is what is the likelihood of what we want to happen out of anything that can happen in general. All right, so now if I give you this question here, find the probability of rolling a composite number on a die. All right, so remember, the way that we would solve this is the event that we want to take place goes in our numerator, and then the total number of outcomes, goes in our denominator. So what we need to do first is we need to figure out, well, what are all the possibilities when we roll a die? Well, we've already discussed this. We have 6 different sides, and we can roll a 1, 2, 3, 4, 5, 6. Right now, we have to make sure, or on your directions on your test, will tell you it's a fair die, which means they all have equally likely chance. So what we need to do is start creating this fraction. Well, I have 1, 2, 3, 4, 5, 6 total outcomes that can occur. So I know that my denominator is going to be a 6. Right? Then I look for composite numbers. Well, 4, that means numbers that have factors more than just 1 in itself. So 4 and 6, they're composite numbers. So that means there are a total of 2 things that we want to take place, so that can happen. 2 different times we can get a composite number. So that means it's going to be 2 over 6. Right? Now the way that you will write this, it'll be P for the probability, and I'm going to say composite, because that's what we're looking for, is equal to 2 over 6, but remember we want it as a decimal, so 0.33, or you can write it as a percent. All right, so for this one, we're saying a small child has a collection of shapes. She chooses one of the shapes at random. Find a probability that it is a triangle. So for A, the first thing I'm going to do is find, well, what are the total number of objects we have that she can choose from? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's a total of 17 different shapes that she can choose from. Right? That is our sample space. That's our total number of outcomes. Right? And now it doesn't say anything about colors. It just says simply that it must be a triangle. So I'm going to go through and count all the triangles. Well, that's a triangle. That's a triangle. So we're at 2, 3, 4, 5. Right? So I'm at 5 triangles. So that means the total number of outcomes that we want or that can take place, how many times we can, if this was a game that we could win, we have 5 different ways that we can choose that triangle. So then the probability of choosing a triangle is equal to 5 over 17. But remember, I want you guys putting that as a decimal. So that's equal to 0.294, which is approximately equal to 29.4%. Either way, whichever way you write it, decimal percent, perfectly fine. I will tell you which decimal to round on a test. All right, now for the next one, B, same thing. We need to create a fraction. We know, well, first let's read the question. It says the child collects all of the circles. So now we're only going to focus solely on all the circles that we have. So here's a circle, 2, 3, 4, 5, 6, and 7. So we have a total of 7 circles. But it's saying she collects all the circles and chooses one of them at random to give to her mother. So we had a total of 1, 2, 3, 4, 5, 6, 7 circles. So that's our total sample space. And it says, what is the probability that she will give her mother a green circle? So this is green, that's 1, that's 2. So there's only 2 circles that are green. So she has the odds of giving her mother a green circle is 2 out of 7. So I'm going to say the probability of choosing a green circle is equal to 2 out of 7. And remember, I want you to write this as a decimal. So 2 out of 7 is going to be approximately 0.286 or 28.6%. All right, now we've only focused on finding a particular outcome. Well, what if I said to you in question 1, not what is the odds of you getting a triangle? What if after A, I said, okay, what is the odds of you not choosing a triangle? Well, instead of you going through and recounting all of these up and trying to figure out however many shapes you have left, that's going to be a little bit of a pain because you have to count the rectangles, you have to count the squares, you have to count the circles, you have to count all of them. We're going to learn something that's called a complement right now. And a complement will make that question very, very easy. All right, so as we talked in class, if we know that something is definitely going to happen, we have the odds of it happening is 100%, or we can think about it as 1, because 1 is 100% when we rewrite it as a percentage. Right? So when we're doing an experiment, something is going to happen. For instance, when we're doing that question where we had the box and we had the circles and triangles, if the girl's going in there and picking a shape, 100% of the time, she's going to pick a shape. Right? It's impossible for her not to go in and grab a shape. So she's always going to happen. So that means the odds of any event happening when we're picking a shape is always going to be 100 or 1. So if we want to find the complement of a specific event, first we denote it. Here is our event E. The complement is written E prime. All right, so that tells us that this is the complement to E. And it's telling us the likelihood that E will not occur. And all we do is first we find the likelihood of E. So let's say rolling a die. So let's roll a 3. So we have 1, 2, 3, 4, 5, 6. So we know before now that the probability of rolling a 3 is going to be equal to 1 over 6. Or you can put this as a decimal if you like. I don't really care. Well, for now, you should be putting it as a decimal. So it's going to be 0.167. And if we want to find the likelihood or the odds, the probability of not rolling a 3, rather than going through and counting 1, 2, 3, 4, 5, we can simply do 1 minus the probability of 3 happening, which we know is 0.167. So 1 minus 0.167. And then that will give us 0.833. So that tells us the likelihood of not rolling a 3. So the probability of not rolling a 3 is equal to 0.833. And that is our complement. The complement tells us the likelihood of the event not taking place. All right, that is it for this video.